Hello and welcome to this video tutorial on writing a simple embedded C program for microcontroller 8051. For this, we will take the help of Keil IDE integrated development environment. So when you open this particular Keil, uh, what I suggest is you go for creating a project. So we will create a new project for square wave generation. So we'll create this particular project onto the in some folder. So let me do it onto the D drive. So there I have a folder called as C program for square wave generation. So there I create some projects name. Let me name it as square wave. Okay, this is the name of the project. So now you have to select the microcontroller. So as this program we will be doing for microcontroller 8051, let me select the manufacturer Intel and let us go for 8051 microcontroller. It is asking you whether you want to copy startup code. So no, just I want to have a very simple program to generate a square wave, so I am not taking the help of the startup code which is available. So I click no here, and then there is an option that there is an editor available here. You can write, you can type your code. So already I have given you one code for generation of square wave. So this is what that particular code is. So now first thing is, whenever you type the code in this particular IDE editor part of this IDE, after that you have to save this particular code with the extension .c, as it is a C program. Now extension will be .c. For few programs we are writing assembly language program for that, so there the extension was .esm. So now I create a file square square.c. Fine. So this is the C file I created. Now what you have to do is you have to add this particular file to your project. Sorry, you have to go to the source group, right click on that and add files to your group. So this is the C file. So this C file gets added to your project as a source group. Now here I can find that square.c. Okay, so when you want to check whether your code is running or not, so what you have to do is you have to type your code. Then this code is ready. So let me check my code is correct or not. So fine, you are getting some errors. Good. So you are getting errors here. So the point is you want to remove these errors. You have to check where the errors are. So there is one warning about ms delay, missing function prototype. Fine. What can be done is target is not created. So let me check what is required. So you have to include this particular file. reg51 space is required, reg51.h. Because of adding this particular file, the special function register declaration is done in this particular file, so that directly I can use the special function register. Fine. Then one thing is, here I have used this particular function, so I need to define this just before this main, so that the main function, we know that there is some function called as ms delay. So after creating this particular defining the function, now let us see what is the code is. Here the main function starts. While one means this is an infinite loop, means continuously I have to generate a square wave. See what I'm doing is port 1 is 55. So this 55 hexadecimal value corresponds to the binary format 0101 0101. Then what I do is I call a delay. I pass a parameter 250 to that particular function, and then again I output AA onto port 1. See, AA corresponds to 10101010, and if 55 corresponds to 01010101. So every pin of port 1 gets complemented because of this type of outputs, but in between that I'm calling delay, and this is the function which is written to generate the delay. So I pass the parameter 250 here, and then I have two for loops which are running inside this particular delay program. So just I am decrementing a variable with some initial value. I time will be 250 value, and there is one more value 1275. So I just go on decrementing that. It will require some time to reach to 0, and indirectly it will require some time to come outside this particular loop. So you can get this particular delay in between the two outputs. So now let me create again the target for this. Yes, so this is what you expect: 0 error, 0 warning. Now what you have to do is you have to create a hex file also if you want to simulate this particular program through Proteus. I'm not going for the simulation. Still, let us go for creating the hex file also. So here you can create that hex file. So now again, if I build, you will get the message is the creating hex file square. See, whenever you are creating the project in some folder for this particular microcontroller, you can find that the hex file gets created by the name of the project. So square is the name of the file and square wave is the name of the project. So with this name the hex file gets created. Now I want to check really my code is working or not. So it can be simulated to the Proteus, but here what we are doing is we are taking the help of Keil itself to view the waveforms also. Prior to that, you all know that you have to debug this particular code through the debugger, and then while debugging, what I can do is I can view the peripheral, I can view the port. So we are dealing with the port 1, so you can view the port 1 contents. So let me run the code. So if I run the code, see, this is how the output is varying. So indirectly, if I concentrate on any pin of the port 1, what I find is for some time it is 1, delay is there, again it is becoming 0 and delay is there. So what I can do is, really if I want to check what type of signal I am getting on this particular port pin, what I can do is there is one option available called as logic analyzer. I stop this simulation, and what I do is I go for that option logic analyzer. In the setup, what I do is I select the port 1.1 pin, port 1.1 pin I select to view the waveform. Fine. So this is, I can check, there is here what is available is port 1. Now what I do is I run my program again in the simulation mode, and then what I find is I should find it as a square wave. So just what now I am finding is the square wave. You can zoom in or zoom out. You can stop this simulation, and then you can zoom in and zoom out. You can check the on time and off time also. So this is how you have generated square wave onto the port 1. Now one interesting thing is alternate pins means, as because we are making the output as 5 and AA, alternate pins every time will be having the output which is complement of each other. So let me add, so presently we have P1.1, let me add one more pin. Let us say it is P1.2. So what I can do is that pin is with the green color, previous was with the red color. Fine. So now two signals are added. So what I do is I again run this, okay, and then I stop it and see what I observe is when one pin is low, other pin is high. When other pin is low, the first pin is high. So this is how I can say that I have generated a square wave onto the port 1 pin by using a simple program for calling delay in between the two outputs. The outputs are high and low. So with this, what we can say is we can generate a square wave using 8051 microcontroller with the help of a C program written which consists of just a calling a delay function, and then that delay function is used to generate the delay, and this delay function or this parameter which you are passing to the delay function will decide your on time, off time, and indirectly that will be deciding the duty cycle as well as the frequency of the square wave which is getting generated from this particular program. Okay, thank you.